Absolutely. And thank you, Nara. Nara has been the the front runner for getting us accepted on IEEE ICBC for this year. He took on the initiative to work on this, given very tight deadlines on research, and Nara took it upon himself to take the initiative to ensure that we get validation from the top minds of the world. Now, when going back to Siddharth's question, um, how do I feel? I feel humbled. I feel that people who have vast experience from web to traditional application development, right? People who have developed SaaS applications and PaaS applications at large scale, um, have been able to write a protocol from the ground up, right? When we started Kandola a year and a half ago, we had a point problem. We had one problem to solve for one industry. We wanted to make one industry more secure and private, like the likes of IoT. And then we quickly realized, that take it as a first step into Web3 for these Web2 stalwarts. And we quickly realized a couple of events, a bunch of feedback from peers. It was evident that there were significant challenges in Web3, both from a technology perspective and from a market or adoption perspective. And the feedback that was loud and clear was that there were fundamental problems. Like, for example, why would you build a supply chain application on the fundamental principle of Alice sending cryptocurrency to Bob, right? Another fundamental question could be, why is there a trifecta of decentralization, security, and scalability, and why are they mutually exclusive? Why aren't decentralized applications real time, right? Why does it take so long to process transactions in the decentralized network, right? Another fundamental question is, why is storage of data being solved primarily from the perspective of storing files, which is unstructured data? Or why is data storage on a decentralized network so expensive? Like Siddharth mentioned, the real cost of storing a megabyte of data on Ethereum today is to the tune of thousands of dollars. Right? 1 megabyte, thousands of dollars. Why? And NFT being all the fad these days, why can't NFTs, the images themselves, be stored on chain, like Siddharth mentioned? So a lot of fundamental questions attacked us right at the beginning, right? And the place from the experience from where we people came from, we started looking at this as a fundamental computing problem that we needed to solve. So we established this kind of a philosophy of change and run at the same time, meaning work on fundamental computer science computing issues with decentralized networks, at the same time be able to deliver on what we're thinking or researching on. And that is where Nara took the research organization and was running on finding out really, solutions to really hard problems that even exist today in the decentralized world. We started with, time-tested computing paradigms like distributed computing, for example, clusters, caches, the likes of console or HCD, right? Or clustered databases or clustered app servers. We started from there. We moved from what it means to get to Byzantine fault tolerance from just being crash fault tolerant. Right? Distributed systems are crash fault tolerant. Byzantine is about permissionless networks, so people from anywhere could come in, and there could be maliciousness and so on. We focused on getting a consensus that works on generic data and not just cryptocurrency, right? Alice sending cryptocurrency to Bob is not what we want to build huge business applications on top of. So our consensus deals with generic data, right? We focused on the consensus being deterministic, not probabilistic, thereby making it real time, right? None of the existing Web2 applications, distributed or otherwise, have a probability associated to whether this transaction will go through or not, right? So we made sure the consensus is atomic and deterministic. We attack the problem of storing data efficiently and retrieving data efficiently, and storing data especially in a structured fashion and not just storing files, right? Who stores data as PDFs or zips, right? You want to be able to store data. For example, if I have an invoice application, I want to store the data as an invoice and be able to query the data as an invoice, right? I have a structure to my invoice and I want to store it exactly in that structure and retrieve it in that structure, right? So we attacked all of these problems that led to what we call the proof of real-time transfer port for short. That is the consensus algorithm that Siddharth alluded to. And when we released the first version, V0.1, the first thing we did was we went to academia. We reached out to the top minds at Carnegie Mellon, at Cornell, at the Indian Institute of Science, and the Hebrew University, etc. A lot of universities. These stand out for me. University of Michigan, for that matter, and these at that time were the leading people. Even today, are the leading people, even in the decentralized computing world and game theory and security, right, and computing in general. And we got a ton of feedback, positive and in some cases critical, and we corrected it iteratively. And now we stand at V0.5, the fifth iteration of the protocol, and that is what has been submitted to the IEEE ICBC, right, the IEEE International Conference on Blockchains and Cryptocurrencies. Now, coming to IEEE, like Nara mentioned, it's a very, very high bar and criteria to be able to publish a full paper in the IEEE International Conference for Blockchain and Cryptocurrency. Of course, accepted that the conference on cryptocurrency and blockchain has only happened for 4 times since I believe 2019. And this is the 5th edition where our full paper has been accepted. But you need to remember the context of not only IEEE, but the Communication Society, which this specific conference belongs to. The Communication Society hosts the ICBC, the International Conference on Blockchain and Cryptocurrency, and IEEE Communication Society, or the ComSoc, as it is called in short, has been pioneering research and applications of things like 2G wireless, the World Wide Web Consortium, HTTP, right? Protocols that the internet is based off of, right? These are the likes of the societies and work that this group does. So the leading minds of the world, literally, right? And ICBC, specifically talking about ICBC 2023, they accept proposals in different formats, full papers, short papers, posters, tutorials, all related to blockchains and cryptocurrencies, as well as emerging areas in blockchains. And the full paper bit is the highest honor because we publish, Nara, keep me honest here, 9 pages plus on our thoughts and ideas that are formalized along with benchmarks and so on. And then there are stringent blind reviews that happen, like Nara mentioned, to get through and be accepted as a full paper in ICBC. The past 4 conferences you've seen, like Siddharth mentioned, the likes of Massachusetts Institute of Technology, MIT, Stanford, IIT Kharagpur, IBM Research. The Hyperledger team has done a lot of papers in the last 4 conferences as well, along with Ethereum, Ripple, and Algorand, like Siddharth mentioned. So great honor. I'm extremely thankful to ICBC, the reviewers, IEEE as a whole, every academician, every professor, every friend and researcher that gave us feedback and course corrected us, with the critical reviews. Of course, the investors, right? And Siddharth will spend some time on it. Hopefully, we have 4 early adopters for our private testnet that is ongoing, and I want to thank them for the confidence in the team, and the team, of course. I want to thank everybody, Shruti, Abhishek, Siddharth, Nara, and the larger team, the satellite team that we have, and the community, of course. Thank you for joining us and celebrating with us.